Our new topic today is talking about internal forces in beams. If your major is construction engineer, all of these topics will be covered in more details in spring semester during structure analysis and the design course. Just to give you a review, one day we covered something called reactions, and we learned we have three types of supports. The first one called fixed support. So this member called beam, and this support on this wall can be considered as fixed. In our course, we are going to assume this fixed looks like this shape. If you have fixed support, we have three reactions: vertical, horizontal, and moment. Sometimes your support looks like hinge, or sometimes we can call it pin support. We have a member here, this member, connected to this support by this assembly. Looks like hinge. If your support looks like hinge, we have two reactions only, one vertical and one horizontal. Sometimes your member, this is a member. This is a member connected to this ground by this cylinder. So it can allow for movement, horizontal movement. Anyway, this shape looks like roller. If you have a roller support, we have only one reaction. This reaction is perpendicular to the base of the roller. Once you set up the reactions based on the type of supports, we have three equilibrium equations. Summation all forces in X equals 0, summation all forces in Y equals 0, summation all moment about any point equals 0. Do you remember what was my recommendation to take moment at a point? Do you remember this recommendation? Taking a moment at any point. This is a general equation, but I highly recommend to take moment at support with the highest number of reactions. Okay? Okay. Just to remind you for something quickly. Guys, to make a big picture or to introduce big story for these topics, any structure in the world like this bridge or this building, any structure, whatever the type of this structure, we have something called external forces. You are right now in your apartment or in your building, you are external force. Your computer is external force. The furniture around you are external forces. All people around you right now are external forces. This train is external forces passing the bridge. All of these stuff called external forces can move in or out from the building. These external forces will create something called internal forces. Guys, the external forces, I can watch them. So right now you can watch your computer, you can watch the desk in front of you, you can watch people around you, you can watch the train passing through the bridge. All of this loading, I can watch them. External forces, you can watch. These external forces will create something called internal forces. Inside each part of the building, we have internal forces. coming from the effect of external forces. But I cannot watch. Cannot watch. I can feel them. These internal forces looks like axial force, shear force, bending moment. These internal forces will create stresses in each part of the building. If these stresses are high and the building cannot support these stresses, collapse will happen to the building. We heard many times before about bridges collapsed or about building collapsed. Why? Why the building collapsed? During the hurricane in South Texas, we found building destroyed. What happened? What happened? We have external forces, in this case, wind. This wind coming to the building, but this wind are strong, very strong. So they created in this building internal forces in three forms. Axial force, and I will explain these internal forces in more details. Wait just a few minutes. Internal forces like axial force, shear forces, and the bending moment. These internal forces created stresses. And because the wind force was very strong, the internal forces are very strong, the stresses created are very high. The material of the building, which is wood or concrete or steel, the material cannot resist, cannot support these stresses. So we can expect collapse of the building. This is the big story for any structure, for any building. Any question so far? Any question so far? So remember, sometimes your building made from steel. Sometimes it's made from wood, timber. Sometimes made from concrete. Sometimes it's made from masonry, brick masonry. What is the difference between this material and this material and this material and this material? The strength. Which one is stronger? What do you think? The strongest one is steel, then concrete, then brick masonry, then wood. So I have to compare between the created stresses and the strength of this material. These materials must be stronger, must be greater than the created stress to make your building safe. Anyway, it's not our issue in this course. We covered before the first structure, which you call trusses. Yeah, I give you a truss, looks like this. Rested on supports, and we have external forces. Yeah, these forces, 50 kb for example, called external forces. These external forces created internal forces. Yeah, we learned how to figure out what is the force in this member. The force in this member called internal force. And this internal force is probably tension and sometimes it's compression. And we learned how to figure them out. So we learned the first building, the first type of structure, which called the trusses. We have external forces and we have internal forces. The only internal forces in this structure is the forces in each member. Now we will talk about beams. This beam in this building. This beam is supported here by this column and this column and this column and this column and this column. So the real shape of the beam looks like this. This is the real shape. Sometimes your beam looks like this. Steel beam, probably. Like this. Sometimes your beam looks like this. Channel. I'm sorry, angle. Sometimes your beam looks like this. Channel. Whatever the shape of the beam, these beams supported here by something called column. In our course, I will assume the beam looks like line. And your support, whatever the type, it's roller or hinge or roller or fixed. So one of you will ask me, what is the meaning of this line? This line represents the center line of this beam. Represent the center line of this beam. Represent the center line of this beam. Represent the center line of this beam. So guys, when I tell you, hey, we have a beam looks like this, you should understand this is in the real life not a line. This line in the real life looks like probably like this, or like this, or like this, or like this. So what is the meaning of this line? This line represents the center line of this real shape. What is the meaning of this support? This support represents something else supporting this beam. Anybody had any question for this point? It's important to understand what's going on. Anybody has any question? Okay. From this slide, I learned the internal forces in beams will be axial force, probably shear force, probably bending moment. Let's start. What is the meaning of axial force? Sometimes we can call it normal forces. What you mean by axial force or normal force? Okay, we have a beam. This beam has center line. If the applied force parallel to the axis of the beam, these external forces will create axial force or normal force. So I'm talking about forces parallel to the axis of the member or parallel to the member itself. Probably this axial force compression, pushing the member, or tension, pulling the member. If these forces pushing, it's a compression, and the compression means negative. If these forces pulling means tension, and these forces will be positive. But you have to remember, the force that make axial force or normal force are forces parallel to the member itself. Parallel to the member itself. I would like for you to watch this video. We have a member. This member, we are applying a vertical force here and another vertical force down. So this member under tension. Can you watch what will happen for this member? It's an experiment.
I don't know. Yeah, it's
Can you watch what's going on with the member? So this member under tension, pulling up and pulling down the member. So we have fracture happen to this member. One more time. Sometimes your member is under compression. So we have a column or member, vertical member, and we are applying vertical force coming down, and we have another force coming up. So this member is under pushing. What will happen? One more time. Slow motion. So guys, probably your member in the structure like this, probably you have a force trying to push this member or trying to pull this member. But in both cases, these forces are parallel to the member itself. If this force is pushing, they are compression. If this force is pulling, they are tension. Any question so far? Anybody has any question? Great. The second internal forces, which called shear forces. I would like to remind you, right now you are sitting in a building. Your load are creating axial force, believe me. But I cannot watch these internal forces. Can you remember? The external forces, I can watch them. I can watch people, I can watch furniture, I can watch train, trucks, cars on the bridge. But I cannot watch the internal forces. I cannot watch the axial force, but I can feel. This is axial force right now in the parts of the structure, the component of your building, the component of your apartment. Sometimes we have internal forces looks like shear forces. What you mean by shear? Shear is critical a little bit. We don't like shear. Shear is not good. We have a part of this beam under the effect of this load coming down. So this part of the beam would like to move down. We have another part of the same beam under the effect of this force coming up. So this part would like to move up. So what will happen here? Shearing. The beam will be sheared at this location because we have a load coming down and we have a load coming up. One of you will ask a good question. How can I find a load coming down and another load coming up? Which case? Do you know which case? Okay, I can tell you. Here is the beam. And you right now, you are sitting here. This beam is supported here by a column. Just explain it to me. We have a reaction coming from this column because this column represents a support. So this support has a reaction, this reaction coming up. And you are sitting at this location, your load is coming down. So this reaction would like to take this part of the beam up. And your load would like to take this part of the beam down. What will happen at this location? Shear. Shear. So if you are sitting beside a column or you are sitting beside a wall, probably you can expect shear will happen because your load coming down, the reaction from the column or from the wall coming up, so the beam or the floor would like to shear at this location. Okay, let's watch this interesting video. Guys, we have a beam. This beam is supported here by this roller support. Can you watch it from left or from south direction? Anyway. And we have another support on the other side. And we have concentrated load at this location coming down and this location coming down. So just to remind you, this load will apply a force coming down. I'm sorry. Apply a force coming down. And this support will apply a reaction coming up. So anybody can tell me where can I expect shear? Anybody can tell me? I need answer. Anybody, any student can answer this question. Where can I expect the shearing? Guys, where? At mid span? Quarter span? Where? Where is the shear will happen? I told you if you have a force coming down and you have a force coming up, so the shear will be in between. That's right. The force at this point coming down, the reaction at this point coming up. This contact point will apply a force coming down, and this support will apply a reaction coming up. So where will be the shear? Oh, I'm sorry. Yeah, it's a big issue. Mm, here is the applied force. Can you watch it right now? Here is the applied force. And we have another applied force here, 2-point load. We have a reaction here. And we have another reaction there. So where can I expect shearing? Here at midspan? Here? Or here? Should be clear right now. Yeah, thank you, Mitch. Thank you, John. Yeah, can you watch? Let's run the video. Did you find anything? Anybody watched any cracks? Guys, did you watch any cracks? Can you watch this little cracks? Can you watch this little cracks? Let's run the video more. The cracks, can you watch? Wow. Failure happened at these locations. Why? Because we have reaction would like to move this part up. We have applied force would like to move this part down. So we can expect shearing in between. So for shear to be happened, we must have two opposite forces. If you would like to watch or to feel that we have a shear, you must have two opposite force. One of them, believe me, will be reaction, because you will ask yourself, which force will push this beam up? Any weight is pushing down. So how can the force pushing up? It's not a real force, it's a reaction force. Okay, so sometimes we have a reaction, we have applied force, two opposite forces, so we can expect in between shear. Guys, any questions so far? Any questions so far? Okay, the third one called bending moment. I would like to ask you to do this experiment at home. If you have a piece of wood, putting on two chairs, two seats, and go ahead and stand on this piece of wood. What do you expect? I'm not expecting failure. I'm not expecting to break up this piece of wood. No, the piece of wood is strong, and you are not too heavy. So I believe this piece of wood will bend like this. Bend. These internal forces called bending moment. We have a moment, this moment trying to bend this beam or this member. We can watch this experimental test. So guys, we have a beam, this beam supported by this support and this support. And we have applied force here. This applied force will make this beam or this member to bend. You can watch the video. So sometimes your external force will make axial force if these forces parallel to the member. Sometimes your external forces will make shear if this force and this force are opposite to each other, and both of them are perpendicular to the member. This force parallel to the member. This force is perpendicular to the member and opposite to each other. The third one, we have a member with external forces perpendicular. This force will cause this member to bend. All of them should be happened at the same time. Let's try. You are sitting at this location right now. So you are applying vertical downward force. I have a question. Your force will cause axial force in which member? Which member? Do you think on beams? This is beams. Or on columns? Right now you are sitting on this floor. So you are making axial force in which part of this structure? On beams or columns? Go back and ask yourself, which force cause axial force? The force parallel to the member. Your force is a vertical force. So this vertical force parallel to which part of this structure? Columns. Thank you. So at this moment, based on your location on the building, on your apartment, you are making axial force on the columns. Why? Because your force is parallel to this column. So axial force exists. Okay? Which member or which part of the building under the effect of shear force? Okay, go back Which force making shear? The force perpendicular to the member. So which member is perpendicular to your force? I believe your force is coming down vertical. So the horizontal member will be under the effect of shear. So right now, at this moment, you are making shear on beams. Why? Because I am perpendicular to these members. The direction of my weight perpendicular to these members. So I'm making shear right now. Okay, I have question. What will happen if my forces is coming in this direction? I'm sorry, how can my force coming in the horizontal direction? Yeah, I can understand my load or my weight is a vertical one. But how can I expect horizontal coming from wind or coming from earthquake? Wind load is a horizontal force. So if you have a horizontal force, this horizontal force will make shear on column and will make axial force on these beams. So I need to remember all of this stuff? No, don't remember all of this stuff. You need only to remember one concept. If the force parallel to the member, it makes axial. If the force perpendicular to the member, it makes shear. If the force perpendicular to the member, it will make moment. You need to remember all of this stuff. You don't need to remember which one is making axial for the column or the beam or whatever. I don't care. You need to remember you have a horizontal force. Okay, the member parallel to this force will be under the effect of axial. The member perpendicular to this force will be under shear and moment. Any question? Any question? I spend a little bit of time to understand what is the meaning, what is the concept of axial force, shear force, and bending moment. If you don't like to understand this concept, it's okay. But it's very important if your major is construction engineer. If you are in civil engineer, no, you need to understand this concept exactly. What is the meaning? Anyway, the first part of this chapter, we have a beam like this beam, probably beam on a bridge or a beam in a building or whatever the real life, and we have applied force. And I will ask you to tell me what is the internal forces at this location. Anybody remember what is the type of internal forces? We have three types. Probably we have axial force. Probably we have shear force. Probably we have bending moment. Sometimes we call axial force normal force. So I'm looking for what is the internal forces at this location. For normal force, I'm gonna call it N. For shear force, I'm gonna call it V. For bending moment, I'm gonna call it M in a capital letter. Okay? So first step, I will ask you, we have a structure, beams, and I'm looking for what is the internal forces at this location. Internal forces means normal, shear, and moment. Sign convention. The positive direction for axial force, you need to assume your force in tension. This is a positive direction. For shear, you need to assume your forces would like to rotate your member clockwise. For moment, you need to assume the direction of these arrows to make your member to smile. This direction and this direction. Just remember, just only remember, to assume the positive direction for axial force, your force must make tension. To assume shear, your shear perpendicular to the member and would like to rotate it clockwise. Your moment would like to make this member to smile. This is a positive direction of your assumption. We have the first example. What is the required? Determine the internal axial force, capital N, shear force, capital V, bending moment, capital M, acting at point C. We have a beam. We have hinge support at A. We have roller support at B. We have moment here. We have concentrated load here. We believe that we have internal forces in this beam, but we are looking only for internal forces at this location only. So we can expect normal or axial force, shear force, and the bending moment inside this beam at this location. We have two steps. First step, you need to figure out what are the values of your reactions. Without reactions, I cannot get the internal forces. If your reactions are wrong, your internal forces must be wrong. So first step, we need to apply for the whole beam summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, because I have two reactions here because it's a hinge. I have one reaction here because it's roller. So first step, we need to figure out the reactions. Second step, we need to figure out the internal forces N, V, and M at point C as required by the problem. I'm gonna continue next time starting with this example. But guys, from this meeting today, I would like everybody to understand this concept. For any building, we have external forces. These external forces, like me and you, your furniture, your computer, your car, anything, you can watch it. These external forces will create internal forces inside each part of the building. I cannot watch these internal forces, but I can feel that we have internal forces. These internal forces, probably axial forces, probably shear forces, probably bending moment. The forces to create axial forces, these forces must be parallel to the member. To create shear forces, these forces must be perpendicular and in opposite direction. To create bending moment, these forces must be perpendicular. Sometimes your forces or your external forces are vertical, like weight of yourself, weight of the furniture, weight of anything around you, because any weight in the world coming down, vertical direction. Sometimes we can expect horizontal forces coming from wind or earthquake. Our topic, our first part in this topic, how can we figure out the internal forces at a specific point, one point only, inside the building. As I told you, first step to solve beam and figure out the internal forces, first step is reactions. One more time, guys, if you still have issue how to calculate reactions, please go back to my recorded videos for this module number 5.